Hello, my name is Paul Gilbert, and I'm the CEO of Quanser. And we're back at Quanser Café, where we're talking about AI and complex modern engineering. I've been inviting a number of global leaders in education to help me unpack some of the issues surrounding how we can modify engineering programs and engineering education to try and get ready to support more complicated systems that exist in the world. You can find out more about the guests in each episode, as well as some of the projects highlighted in our conversations by visiting the links in the podcast description. If you're listening or want to watch the full podcast with subtitles, visit the Quanser Café on quanser.com. Today we're addressing another topic that's critical for shaping the future of engineering: embedding an interdisciplinary approach in engineering education. As the world becomes more complex, so do the challenges facing engineers, making it essential to break down traditional academic silos. I've invited 3 thought leaders to share their insights on how we can integrate fields like business, social sciences, and technology to create more holistic, innovative education models. Dr. Yannis Yortsos, Dr. Ken Ball, and Dr. Gerhard Müller are back with us to help unpack the possibilities and challenges of interdisciplinary learning and why it's so important for preparing the next generation of engineers. Dr. Yannis Yortsos, Dean of the University of Southern California Viterbi School of Engineering, gets us started by defining the distinctions between multidisciplinary, interdisciplinary, and transdisciplinary education, and why these approaches are transforming the way students learn and innovate. So welcome back, Yannis, and over to you.
Okay, multidisciplinary, I associate typically with, let's say, you are an engineering student and you take a minor. And this minor, let's say, is in business or it is in cinema or something like that. To me, that's a multidisciplinary education. Maybe you can also take something minor in humanities or something.
Okay.
Many universities do that, and it's actually an important component of your education.
Mm-hmm.
Transdisciplinary is the situation when you have students, let's say, from 2 different majors, and I'll give you a particular example at USC in computer science and cinematic arts.
Okay.
That they take almost a year of joint courses in the area of games. Games, I'm talking about computer games.
Yeah.
In which engineering students provide, they work together hand in hand with cinematic art students to produce interesting new games for educational purposes and other things. We do have this program at USC, actually. The games program, CS Games, that is the top games program in the nation and I think in the world. And that is a truly interdisciplinary program. The students that graduate have a degree in in engineering and in cinema. In other words, they maintain their identity, but they have been immersed for a long time in a joint program. And then you have the transdisciplinary approach. So transdisciplinary so we have a new program we call AI for Business.
Okay.
So this is a program in which you are neither an engineer nor a business student. You are a new entity that is characterized by AI for Business. You take significant courses from engineering, particularly AI related, and significant courses from business related to business. And this person graduates with this degree, AI for Business. So it is a transdisciplinary degree. It is the same degrees that evolve in the past when you talk about biomedical engineering. People started with maybe mechanical, maybe some biology, whatever. Then you created this new transdisciplinary degree called biomedical or aerospace engineering or even mechanical engineering, right? Started in a different way. So this creates these transdisciplinary degrees that then become degrees of their own. So this is my definition of these 3 degrees.
I like that.
3 words.
I really like that, and I guess so. Now, do you? So you have people that are teaching that from the engineering side or the computer science side, and people that are teaching it from the business side.
Currently, the students are taking courses from AI and then for business.
Yeah.
I'm anticipating that as this program becomes much more popular, by the way, it's extremely popular. We have all kinds of applications for the program.
Oh, I can imagine. If I was younger, I would love to do that program. It sounds fascinating.
Right. It evolves. I think it will evolve into its own major that is a new major, and maybe we'll have faculty associated not associated with their job will be to do AI for business.
So, I mean, that raises the question to me, because I know in many universities around the world, you have the engineering school, and you have the business school, and you have other schools, and you have budgets, and you have constraints, and you have buildings, and you have faculty,
Right.
and you're the dean of the engineering program,
Right.
and there's the dean of the business program, right?
Correct.
And you have to arm wrestle over a whole bunch of things, I'm sure. But how did you? And I know, because you're a forward-thinking person, so I don't think you're as territorial as that, if I may use that term.
Yeah.
How do you go about kind of squaring that circle and making that work together again in such a large campus?
So fundamental to all of this at some point is, okay, so the most important thing is to make sure that you don't sacrifice quality, and then quality remains of the at the level and degree that everybody wants from a scholarly perspective. But other than that, everything else, Paul, becomes a matter of finances and money.
Yeah.
And I am always a believer that things that involve money can always be solved, because you can always make some sort of a negotiation or something that you can solve the problem. I can give you an example, because we have the same situation. We had the same situation for a long time in our students that take math courses.
Right.
So the math courses in any university that engineering students take are usually from the math department.
Right.
And, for quite a while, long time ago, our students were not happy with the math instruction. And the point was that the people who were teaching math were, don't really care too much about teaching the math. It was like, okay, I have to go teach calculus, okay, at 9 o'clock and then leave at 10, whatever. And not care too much about everything else. So we struck a deal with the math department, and we said the following: we are going to use engineering professors to teach math to engineering students. You keep the tuition, you pay the faculty salary, and then we will be happy with everything else. And our students got a lot more than because they were taught math from an engineering professor.
From an engineering standpoint, right?
The math department had no problem in getting the tuition and then simply paying the salary of the faculty member, which was not bad. And we have this system for more than 20 years now, and works perfectly well. And so, as I say, with money you can move around, so this is not a problem.
Well, no, that's interesting, because I do hear. I mean, I travel quite a bit, and I hear this problem about math all over the place. And then you start talking about having an AI business course, and
same thing for AI and business. Absolutely.
I mean, this kind of conversation, the transformation of engineering is something which seems to be a constant at USC. It's not you wake up one day and say, no, we're going to change everything today. It's something you evolve over time. And those AI courses that you put in 5 years ago, they've probably changed today. They're probably different than they were.
Yes, of course they are. We keep working on them, and there's also data sciences components as well. We have also a program at USC in engineering that teaches AI and skills and also data science to non-STEM majors, which also is an important part. And it's very popular because, let's say you are a political science major or a history major, and you need to learn a little bit about data science or even AI, then that's something, it's kind of like an AI version that doesn't require the degree of sophistication, let's say, that you need for a STEM major.
Dr. Yannis Yortsos there. We'll be hearing more from Yannis in one of our final episodes this season. So on to another area I want to explore in our theme today, which is around assessment. I caught up with Dr. Ken Ball, Dean of the College of Engineering and Computing at George Mason University, who shared more on the approaches his university are taking to ensure equity and fairness in evaluating students in multi, inter, and transdisciplinary studies.
Right. Well, so there again, we very much believe in outcomes that are defined and measurable, and continuous improvement. And so, for example, our undergraduate programs are all ABET accredited, and ABET, of course, is the organization that accredits engineering and technology programs and computing programs.
Mhm.
And so that's in our culture. We always want to know what we're doing and why. And so whether it's a new program or continuous improvement on existing programs, we always want to know what our outcomes are. And we want to be able to define those outcomes and come up with a continuous improvement process where we can measure those outcomes and gauge them against our standards and then make adjustments. We also want to be sure we know what our objectives are for our programs, kind of our broader impact on what we expect our students to do once they graduate and begin their working careers. And so, and also, as we're a large public research institution, we're the largest public research institution in Virginia. And so we also want to be cognizant of our mission as a public university, a public research university, and the vision and mission of the university. We want to be sure that our outcomes and our own objectives for our programs align with that. And so that's really what we do. We constantly want to be sure that we have measurable outcomes, and we want both direct and indirect measures. And so we put a program together where we're sure that we're really achieving what we hope to achieve.
So do your students get credits from interdisciplinary, like if they're working with the business students and government and policy students and they're doing a project, each of the students get credits for their respective courses based on those?
Well, again, yes, if it's curricular, right? So they can be on a design team that has students from outside the college that are participating in the design team, or they can take courses and electives that are offered by professors, faculty, and other colleges, or they can, again, through their work experiences or their even in the student organizations, right? So a big part of the co-curricular learning that goes on in university are, for example, competitions and challenges. We just recently, in the spring, we had a Defend the Republic competition that we had, I forget the exact number of universities, something like 20 or 25 universities, mostly on the East Coast, but some came as far away as Texas and the Midwest. And it was a lighter than air drone competition. We went to the basketball arena and they were flying, blimps around. And it was sort of like Harry Potter and Quidditch, where
Oh, so you had like a game, like a task or course they had?
They got points for steering objects through these hoops that were suspended from the ceiling
Amazing.
of the arena. But the cool thing is they were also allowed to attack other teams, and so it had an offensive and a defensive component to it. The students loved it. It's very exciting and very challenging, very much like our own version of academic Olympics. And but that's an example where there's tremendous learning that goes on. Some of the teams even have art students in there because they want their blimps to be very fancy and cool looking, right? And so they bring in students from all over that can work on teams and compete with each other and win prizes. And we are able to get sponsorship. And in this case, that was sponsored by our Office of Naval Research, and we're very happy to have those kinds of sponsors. So again, it's all about working with your partners and finding opportunities for students to learn both inside and outside the classroom. But it's also important especially for younger people, that they can do fun things and they can see that they have a great career and they can enjoy doing it.
Well, I was gonna kind of pick up on that because the motivational piece to get the students engaged is always really important, so they can understand the authenticity of what you're trying to do. Why am I learning this theory? Why am I having to deal with this problem? Well, there's a reason you're trying to deal with it, and to get them engaged in a fun project. That's the kind of the dream, right? What were you finding out in terms of outcomes? Are you able to reflect back, if you go back over the last 5-10 years and kind of assess how the students' outcomes have developed by is there any kind of work that you're doing to kind of check that to see how much it's improved?
Oh yeah, all the time. We always take the view that no matter how great we think we're doing, we can always do better.
Yep.
And things change, right? You just don't sit back and assume that nothing's ever changing. There's always new technologies coming out and new threats, especially in the digital world.
Yep.
And so you've got to adapt, and you have to be sure that you're staying current. And so we certainly do that. The example I just gave of the Defend the Republic blimp competition, there's also aspects of being able to work on a team and teamwork and working with people from different backgrounds and experiences and formal training. And the leadership side of it too is, everyone has a role to play, and they can, develop and hone their leadership skills as well. So, and communication skills, you can have the world's greatest technology, but if you can't explain it and you can't present it, then, it's going to limit how much impact you're going to have and what your opportunities are going to be.
Thanks, Ken. A pleasure, as always, speaking with you. Concluding this episode, I'm back with Dr. Gerhard Müller from the Technical University of Munich, where we explore structural and organizational elements that make interdisciplinary education possible. Let's hear more from Gerhard about how educators from different domains are getting together to create experiences which are valuable to students.
Well, I of course, it is for some of them not the typical daily experience. For others, of course, they are used to these approaches. I think it is very important to bring into the university context groups that are kind of dedicated by themselves to create these connections with the other disciplines. So the commitment can be enhanced, for example, in our case at the Technical University of Munich, by a decision to bring in the economics into the structure with a clear notion that we will create study programs which foster the interdisciplinarity and thus force also the faculty members to communicate adequately. We did the same with our Tomb School of Social Science and Technology, where we also brought in people from political sciences, social sciences, philosophy, law, but with a clear, let's say, narrative behind that states that we are convinced that a technical university and the students that are educated there need this connection. Once you do that, I think it is much easier and much more positive actually to do it. If you bring disciplines which are of course based in their individual track and just ask them, could you please work together? It's much more difficult, I think.
No, I really like that idea of having someone who wakes up every single day, every morning, every week, and they're thinking about how can I create an environment and bring people in from different disciplines and monitor it and improve it and make it, fulfilling, make the experience motivational and so on. I like that approach very much.
Yeah, I think that you have to do one really has to be aware that everybody is in his or her setting. And you just can't do it by just asking, well, this would be a nice idea, do it, because it's also, well, heavy work to do it actually. So it's good to create a framing, to create a narrative, to create actually a setup which kind of incorporates this attitude. And I think you have to do that.
Thank you, Dr. Müller. Well, that brings us to the end of today's episode of Quanser Café. A big thank you to Yannis, Ken, and Gerhard for sharing your expertise and experiences. It's clear that the future of engineering lies in breaking down traditional boundaries and creating environments where different disciplines can collaborate to solve real-world problems. Whether it's blending AI with business, integrating social sciences into technical programs, or fostering hands-on project-based learning, these approaches are essential for preparing the engineers of tomorrow. Stay tuned for our next episode, where we'll explore tailored learning, student engagement, and motivation. We're keen to hear your thoughts about the season or potential topics or guests to feature in future episodes. Please leave comments or connect with me on LinkedIn. And to learn more about Quanser, visit quanser.com. I'm Paul Gilbert, and this is the Quanser Café. Thank you so much for listening. Goodbye.